studying BTech second year in all science of technology in the Department of Computer Science. Today my tech talk presentation is normal forms in Mfcs. So what is normal forms? If a given statement formula involves n atomic variables, we have two possible combinations of truth values of statement replacing the variables. The formula A is a tautology. If A has the truth value T for all possible assignment of the truth values to the variables P1, P2 and so on Pn, and A is called a contradiction. If A has the truth value F for all possible assignment of the truth value of the n variables, A is said to be satisfiable if A has the truth value T for at least one combination of truth values assigned to P1, P2 and so on Pn. The problem of determining whether a given statement formula is a tautology or a contradiction is called a decision problem. The construction of truth table involves a finite number of steps, but the construction may not be practical. We therefore reduce the given statement formula to normal form and find whether a given statement formula is tautology or contradiction, or at least statistical place of distinction in our current discussion. A product of the variable and their negations in formula is called elementary product. Similarly, a sum of the variables and their negations in a formula is called an elementary sum. Let P and Q be any atomic variables, then P cap Q minus Q cap P minus P minus P and Q cap minus P are some examples of elementary products. On the other hand, P minus P, VQ minus Q, V minus P, and are some examples of elementary sums. Any part of an elementary sum product which is itself elementary sum or product is called a factor of the original elementary sum or product. Thus, minus Q cap minus P and minus Q cap P are some of the factors of minus Q cap P cap minus P. Disjunctive normal form DNF. A formula which is equivalent to a given formula and which consists of a sum of elementary products is called a disjunctive normal form of the given formula. Example: obtain disjunctive normal form as you can the solution here, which is required disjunctive normal form. Note: the DNF of a given formula is not unique. Conjunctive normal form. A form which is equivalent to a given formula and which consists of a product of elementary sum is called a conjunctive normal form of the formula. The method for obtaining conjunction normal form of a given formula is similar to the one given to the disjunctive normal form. Again, the conjunctive several form is not unique. Principal disjunctive normal form. In a section, we will discuss the concept of principal disjunctive normal form, PDNF. Midterms for a given number of variables. The midterms consist of conjunctions in which each statement variable or its negation, but not both, appears only once. Let P and Q be the two statement variables, then there are 2 power 2 midterms given by the P cap Q, P cap minus Q, minus P cap Q and minus P cap minus Q. Midterms are the variables as you can see here. From the truth table of these midterms of P and Q, it is clear that as you can see the table of truth table, that is T means true or F means false. Number 2, midterms are equivalent. No two. Each term has the truth value T for exactly one combination of the truth values of the variables P and Q. Definition: for a given formula, an equivalent formula consisting of disjunctive of minterms only. The principal disjunctive normal form is called the sum of the products and commercial form. The method of using the rule, conditional proof, and the negation of incommensurate set premises is called indirect method proof or proof by contraction. In order to show that a conclusion C follows logically from the premises h1, h2, and so on hn, we assume the C is false and consider minus C is an additional premise if the new set of premises in inconsistent, so that they imply a contradiction. Therefore, the assumption that minus C doesn't not hold. Hence, C is the true whenever h1, h2, and so on hn are true. The C follows logically from the promises h1, h2, and so on hn. And this is all about normal forms. And thank you.